In this video, we're going to take a look at solving quadratic equations using the quadratic formula. Keep in mind that there are several ways to solve quadratic equations. This video specifically focuses on the quadratic formula. You have to be well versed in all methods for solving quadratics. Again, this video just does the quadratic formula. This video assumes that you have some ability to read a standard form, and as well as the ability to simplify radicals to an exact value. Both of these skills come up in this video. So the directions here say, please solve for x, give exact and estimated values to the nearest hundredth where appropriate. All right, before we can do that, we need to take a look at what the heck is this quadratic formula thing. Well, it's basically a magic box that spits out answers, and it's a little bit of a complex box, so let's take a look at it. It says, if you are given ax squared plus bx plus c that is equal to 0, again, it must be equal to 0, you are able to solve for x by simply doing this formula, which states the quantity of the opposite of b plus or minus the square root of the quantity b squared minus 4ac, all divided by 2 times a. So if you notice there, we just have to be able to plug in values for a, b, and c, and then PEMDAS appropriately. Okay, well, where do those values for a, b, and c come from? They come from the given form of the equation. We notice that a is the multiplier of the quadratic term, b is the multiplier of the linear term, and c is the constant term. It is called a constant because it in fact has no variable with it. Okay, so let's take a look at these examples here. Again, we're going to keep in mind that we're going to give an exact value and an estimated value to the nearest hundredth where appropriate. Okay, so we have x squared minus 10x minus 24 equals 0. Well, this in fact is a quadratic that's equal to 0. I see it's of degree 2, so it's quadratic. It shouldn't be too hard to identify a, b, and c here. They are in fact a equals 1, b equals negative 10, and c equals negative 24. Okay? You have to be able to say what those values are. It's great to make a little chart. Okay, so now I'm going to do some color changing here to show you that these, in fact, just get plugged into this formula. So we do x equals the opposite of b, which is negative 10, plus or minus the square root of b, which is negative 10, squared minus 4ac, the a being 1, the c being negative 24, all divided by 2 times a, which in this case is 1. Now, before I go any further, I really cannot reiterate this enough. When you plug in here, it is imperative that you use parentheses. Parentheses are absolutely a fabulous tool when plugging in. But if you don't write your parentheses there, chances are you will not type them on your calculator, and you will in fact make a mistake and not even know it. Okay, so now it's just a matter of being able to simplify and adhere to the order of operations. Well, I'll try and overview this quickly and say, well, I'm going to really be simplifying this area, and this area of the problem, because doing so does adhere to the order of operations. So I will do x equals the opposite of negative 10, which is 10, plus or minus the square root of, good time to go on my calculator. Okay, you can do that part by hand, but it's not a bad time to go to your calculator and do negative 10, again, in parentheses squared, minus 4 times 1 times negative 24. If you notice, I'm not doing the square root, I'm just getting this value, which is 196. Okay, trying to take my time. The pace by which I'm writing this is a recommended pace. You really should take your time and do that. Now, the denominator is here, obviously, 2. So continuing on, we are going to get a little more space here. X equals 10 plus or minus. Now I have to simplify the square root of 196. Well, I have a sneaking suspicion here that 196 is a perfect square, so I in fact get an integer, when I square root it, I get 14, all divided by 2. Here, it's a great time to split the problem into 10 plus 14 over 2, or 10, excuse me, I should say and, 10 minus 14 over 2. Continuing on, I get 24 over 2 and negative 4 over 2, which in fact will give me x equals 12, x equals negative 2. Just to change the size of the page here for a moment. It is a solve problem. I can use my calculator and the store button to go 12 store x and then just type the original problem of x squared minus 10x minus 24. The result in the problem said it was 0. I'm getting 0 on my calculator. Similarly, doing negative 2 store x, second enter to bring the problem back. And I get 0 using that as well, which means my answer checks out. Now, before I go any further, I want you to note something. We've said there's multiple methods for doing the quadratic formula. In this problem, if you notice, I got integer answers. Integer answers actually indicate that I could have taken the original problem and probably factored it and used the zero product property. That would have been much shorter. If you want to pause the video, try and play with that and see if you can do that, because you have to be fluent in the zero product property as well. Okay? Okay, for the sake of space, I'm just going to shrink this down a little bit. Okay? And I'll go back to page width. I'll take a look at my second example, okay, which it says the opposite of x squared plus 9 equals 0. Okay? Well, to do this, I need to be able to identify a, b, and c. And I'm actually going to rewrite this problem just for a second for clarity. What would make sense to say that it's negative 1x squared, which obviously is equivalent to the first term. The thing you need to see is that there are 0 x's per se. There is no linear term. So in fact, if I put in plus 0x, I'm not changing the problem because that value is 0, and then saying plus 9 equals 0. Well, we obviously have a quadratic because the degree of the polynomial is 2. And again, it must be equal to 0 for you to be able to use that formula. Okay? So, just a quick chart of a equals negative 1, b equals 0, and c equals 9. And then from there, I'll use my quadratic formula. Just go x equals the opposite of 0 plus or minus the square root of the quantity 0 squared minus 4 times a, which is negative 1, times c, which is 9. All divided by 2 times a, which is negative 1. Again, good idea right here to be able to put that value in parentheses when we plug in. I didn't miss that per se. You don't have to. You really should. It doesn't matter here because the value I plugged in was positive, but if you were plugging in a negative, it's essential. You are going to get it wrong if you don't. So trying to adhere to using parentheses when we plug in makes a lot of sense. It saves a lot of headaches. So continuing to simplify, I'm going to simplify in these areas here because they're sort of areas that if I do that, just takes me through a good PEMDAS type of approach to the problem. So I'm going to get x equals 0 plus or minus the square root of 0 squared minus 4 times negative 1 times 9. We see is just to be able to multiply these three terms because I'll be adding that to 0 and getting 36. Excuse me. Over negative 2, which is going to give me plus or minus 6 over negative 2, which in splitting that problem there, we're going to get 6 over negative 2 and negative 6 over negative 2, which is actually going to give me negative 3 and 3. Again, if we notice here, I did get integer answers. Okay? Integer answers or terminating decimals, anytime you get a rational answer, it lends itself to saying, wow, I probably could have factored this. You actually, if you look here, you probably could have taken that expression and factored it. Just real quickly off to the side, I'll rewrite it. 9 minus x squared. Well, that's a difference of 2 squares. You probably could have factored that very quickly. Okay? Just to check my answer now, though, I'm going to do 3 store x. Okay? And see if it jives with the original equation, which is the opposite of x squared plus 9. Hopefully that yields 0, and it does. Similarly, if I did negative 3 store x and second enter twice to bring back 2 previous lines, gets me 0 as well. Okay, and just let me shrink that down a little bit for space. And I'm going to take a look at this last example. It says 2x squared equals 9 plus 4x. Well, hopefully this jumps out at you quickly to say, something not quite right here. What's not quite right is I do not have a quadratic that's equal to 0. I do have a quadratic because I could tell that where it says 2x squared, the x squared gives away that it's a quadratic because it's of degree 2. But I'm going to need to make this equation equal to 0. And to do that, I'm going to subtract 9 from both sides and subtract 4x from both sides. So if you notice, I actually will start out with writing this problem as 2x squared minus 4x minus 9 equals 0. Okay? So from there, I can legitimately say what the values of a, b, and c are. A is 2, b is negative 4, and c is negative 9. Okay? Now this example is going to be a little harder. It's not a problem that we could have factored from the beginning. And if you notice, we just see that the 2 times negative 9 is negative 18. There are no factors of negative 18 that make negative 4. So I do want to say here, the quadratic formula does do problems that can be factored. It's more appropriately used for quadratics that cannot be factored. And you need to understand this right now. If you cannot factor the quadratic when you're solving it, it doesn't mean there's not an answer. There might not be an answer. It just means you can't get it by factoring. So the quadratic formula is kind of a duct tape method, really, where it does a larger variety of problems, if you will. Okay, so getting this set up, we're going to get x equals the opposite of b, which is negative 4, plus or minus the square root of the quantity of negative 4 squared minus 4 times a, which is 2, times c, which is negative 9, all divided by 2a, which is 2 times 2. Again, trying to put some focus around simplifying these values here when I go to approach this. It's a good way of going about it. 4 plus or minus the square root of, not a bad time to go to my calculator. And again, that negative 4 needs to be in parentheses. And the value of b squared minus 4ac will be 88. And that will be all divided by 4. Okay, well, we see here, we talked about you're going to have to be comfortable with simplifying a radical, and now's the time to do that. Well, I take 88, the root of 88, and I split it into 4 times 22. Now, why did I do that again? You have to be comfortable realizing that 4 is the biggest perfect square that goes into 88, giving me a value of 2 root 22 when I simplify it. So I'm going to put that value back into the problem. I'll put it in red here so you can see the swap. And just continue from there. Now you have to be comfortable with the idea that when we go to simplify this radical, you're going to divide the 2 terms on top by 4, which allows you to do 4 over 4 is 1. And 2 over 4 is going to be a half. We do the symbol of plus minus. 2 over 4 is going to be 1/2 root 22. So this is in fact 2 values. The first one is 1 plus 1/2 root 22. And the second one is 1 minus 1/2 root 22. Now these are exact values. They're exact in that I did not round them, okay? I'm going to go to my calculator here and get the estimated values, as the directions indicate, where it says to estimate the nearest hundredth. That is done simply by typing those expressions, where we get 1 plus 1/2 times the square root of 22. This gives me a decimal of 3.35 when I round it. So I will say x is about 3.35. I'll say end. And then I'm going to use my second enter to go back to this line, which is great to just change this plus to a minus. And then I get negative 1.35 as my other estimated value. Okay? Now, I'm going to put both of these values in the calculator. I'm going to put the exact ones in. So I'm not actually going to retype these. I'll just take them as is. So I'm going to take this value, which is the 1 minus 1/2 root 22, and go store x. And then I'm going to go back to the original expression, which says 2x squared. Then I'm going to hit second test, because I have variables on both sides. Okay? And then I'm going to continue to type 9 plus 4x. And remember that little rhyme with this, if you've seen it before or heard it before. It's 1 is done and O is no. So the 1 means that that is a true statement, which means this answer checks out, which is the minus, right? And now I need to just take a second to see if the plus does. Well, I have that in my calculator, so I'll go second enter, second enter, second enter, second enter. Probably easier to do this than type it again. Then I'll go store x. And then I just need to go second enter to bring back this equation and hope for a 1, which means my answer creates a true statement. Okay? So this one checked out. Okay, so what do we have here again? You need to realize that these are the exact values. And down here in pink are the estimated values. Now the estimated values are probably a little more useful if you've got to go to the number line and find out where they are, and you'll see that you'll need to do that when in fact graphing a quadratic, because these represent the x-intercepts. Okay? But what you should be tending to think you would be writing there potentially, depending on the directions of the problem, is the exact values. So I like these answers, and if you notice just briefly in previous problems, I was not in a situation where I needed to write estimated answers, because I in fact got answers that did not need to be rounded at all because they were integers. So enjoy. This is a magic box formula. Okay? It's very powerful. You have to have a power to wield it, which means you have to be able to set the problem up well, but then also simplify it. Okay? Keep in mind, too, is this entire formula, once you get it set up, you could type the entire thing in your calculator, but you do need to do what I did to sort of show your work. I feel like as a math teacher, the way I modeled these problems is the bare minimum of the showing of your work that's appropriate for your level. Okay, so enjoy. Feel free to practice, and keep in mind there are multiple methods for solving quadratic equations. This is the one that is called the quadratic formula. Enjoy.